Okay. Maybe continue this discussion offline, but thank you so much. That was a great talk. I'm going to finish out the session with Romy Froemer, who is going to talk to us about ice cream.
So two things. A, I did not rip off Caroline Charpentier. I didn't know she also started with an ice cream thing. Second thing, I think the light is fixed, but if it's not, we've all been sitting for a long time. If the light does something funky, we all get up, we shake out our legs, and then we sit back down. Okay, that's our cue. All right. Now I have your attention. That's also the topic of my talk. All right. Yes. So weather is nice again. We're maybe having some ice cream later. I'm going to talk a little bit about how we think deciding ice cream flavors works, and other things that are based on how much we do or don't like things. Okay, so imagine finding yourself at the ice cream parlor and having to make decisions. We have some experts in the room on how to do that, and people have extensively written about it. For instance, here a quote from a Nature Neuroscience paper: "There is a growing consensus in behavioral neuroscience that the brain makes simple choices by first assigning a value to all of the options under consideration and then comparing them." And now, based on those insights, the authors have said, well, now we can actually study like how this comparison unfolds. They were building on a famous model of decision-making, which is the drift diffusion model that originated in a different domain of decision-making, but it seemed worthwhile to apply that same model to value-based choice. For those of you who are not familiar with that, so imagine you choosing between apple and chocolate flavor ice cream. You only have noisy insights into each of the flavors at any given point in time. So what you do, obviously, is you don't just like take one snippet of information and then make a choice based on that, but you actually integrate this noisy information over time to get rid of the noise. And ultimately, to put it very simply, what you're doing is like you're flipping a biased coin repeatedly and you're just counting which one wins, up to a certain point where you have a predefined, we're calling this barrier here, a predefined level of evidence for either one, right? Like if the apple wins, you go up. If the chocolate wins, you go down. How quickly you go in either direction is determined by what I call what is called the drift rate. And in this example, Apple won sufficiently often to reach that upper bound, and so Apple was chosen. We all good on that? Excellent. This assumes that all the information is essentially available, like it's noised up, but it's available the whole time, right? But that's not really how this works when we actually choose ice cream, right? Usually, like we go there and then we look at one thing and then we think about that for a little bit. And like, you know, I don't know, this is kind of artificial color. I don't know how I feel about that. What else is out there? Okay, like that looks good. That's probably a pretty intense chocolate flavor. And so we kind of keep moving around like in our option space and like consider these things, right? So clearly what we attend to plays a role in what information we have access to at a given time and how high quality that information is. And actually this paper that I was quoting here introduced that very idea. Right. And so what they said is like attention is actually really, really important and it should affect how we compare our options. And so they kind of amended this. Man, I was going to. I'm not going to do the clicking all the way back thing, but now we've already seen. Here. Okay. I was gonna say, and if that happens, we all do this, and now I regret that I didn't do that. Okay. They made an extension, and they basically said, like, well, the thing that you're focusing on, you actually have more information about. So you should discount all the information you're getting about the stuff that you're not currently looking at because it's not that good, right? And so what you see then is that there isn't one drift rate that is constant over time. So the you're not being pulled in the same direction consistently, but the way you're being pulled kind of varies depending on like what you're currently looking at. So like the gray background here is like looking at the first option you saw, so that was the apple, and then you shift your gaze to chocolate. And while before you were kind of like intrigued by the apple, now you're really intrigued by the chocolate, but then you shift your gaze back. And then now apple is like really great again, and ultimately you choose apple, right? So this was a really important insight that they had there, that, you know, not all the information is available to the same extent all the time, and our choices are influenced by that. The issue that I personally have with that model is that they don't really explain like how attention happens, right? They kind of say like, well, we had a look, there wasn't really anything there. It seems like attention just happens, but if we know what the attention did, we kind of can tell you what happens to choices. And that's a bit unsatisfying, right? And it's not that attention just happens. Like attention is allocated in a very you know, meaningful way. And actually, there's been some really amazing work there just recently. 2 papers were published basically the same day, describing how attention should optimally be allocated when making these types of decisions. And I'm blatantly ripping off one of the figures here from Anthony Yang's paper, actually, because I think it's really a nice explanation of the process, where essentially at a given point in time, you don't just have a choice between the options that you're choosing from, but you also have a choice between continuing to accumulate evidence about or information about the option you're currently considering, right, that you're attending to, or you can choose to shift your gaze and start accumulating information more about the alternative option. Or you can say, I've seen enough, this is it, I am going with, well, whatever, a donut. Okay? Does that make sense to everybody? And that is like beautiful. They've like shown that this is what people ought to do, and that is also kind of what people are doing. So that's really nice. So the conclusion from that work is that allocating attention is in itself a decision. And another thing we can see here is that there's actually this nice parallel to learning, right? Like we have all of this great work on telling us how people sample information in learning, and there's a clear like link here between everything we've learned about information seeking in that domain and like what people should be doing at this like much shorter time scale when they're making decisions among options. Okay, and we can test whether some of those principles also apply there. Okay. So what I'm going to talk to you about in my talk today is basically how we've tried to unpack these things. So we can unfold this like Bayesian value estimation bit here that just has this tiny box into, you know, like having a prior, iteratively updating that prior, and then combining information about multiple options and like, you know, testing predictions about, that's what the researcher does. So people would combine that information and should show systematic deviations from optimal choice as a function of what happened in their, say, exploration. And in study 1, we're basically testing that. And then in study 2, we're going to try and put this together with this active information search that people do when they can allocate their gaze wherever they want to. And then in the third study, I'm going to look at how that varies as a function of like what people are looking at these options for. So what type of choice are they trying to make? Let's go. Okay. This is a very, very sensitive clicker. Okay, but if it happens again, you all do this, okay? Okay, here we go. This is a study that we that I've talked about before at RLDM in 2019, and we just had it accepted. So please take time. Up there in the corner, you see my collaborator, Fred Calloway, who sadly is not here, but he's always here in our hearts. And yeah, we've done this work together, and he's really done like most of the modeling. And one of these wonderful models that I just told you about that really made a big advance here in that field is actually by him. Okay, so we wanted to get at this value estimation thing, and we wanted to better understand the role that attention plays in value-based choice. And there's a key issue here. Well, yeah, and like let's talk about value estimation first. So here we're building on work by Raphael Polanyi, who said like, well, you can code value in an efficient way if you basically do Bayesian inference, right? So you have this like expectation, this prior of like where different values live on a continuum. And I'm building this. So you have different options living along a continuum from things that you dislike to things that you like, and you can basically construct this. You can construct this distribution, and if each of these options have a value assigned, you will have some that are like, towards the lower end, some that are towards the higher end. And so going into a given context, not knowing what the values of options are specifically for individual options, you kind of know where they're going to live, right? Where are they likely to live? And so you can make the coding or the inference on these values more efficient by starting with that prior that is well calibrated to that environment. Okay. I don't know if I want to work with this clicker. And nobody's done this. Okay. So that's our thing. So now the light blue part of this distribution is stuff that you don't like and that all else being equal, you're not very likely to choose, right? Because it's the stuff that is below the average. The stuff with the dark blue shading is stuff that is above average. So all else being equal, you're kind of more likely to choose that stuff, and that's the stuff that you like. Okay. So now, starting from this reference distribution, assume I give you two options that live somewhere on the thing. You have to figure out what the values of these options are. So teapot and string lights, in case you cannot identify what these things are. They have some true value, but you don't know what it is. That true value has basically a mean and a distribution. So the means are locations on that distribution, but there's some noise around it. And for simplicity in this talk, I'm going to assume that the precision of these distributions is the same for both options. If you want to know more about when that's not the case, you can look at the paper. We have a preprint out. Okay. Now, what happens when you actually choose among those options is that you, in the beginning, have no idea. So your best guess is that they have the reference value, right? The average value of the distribution you start from. And now you can basically iteratively update that when you shift your gaze to alternative, like to the options. So you look at the teapot, you're kind of thinking about like, okay, whatever, that's a pretty teapot. And then you use that sample to update the value you assign to that, or you infer about that option. So now you're moving away from the mean. It's a little bit higher. You get some more information. It goes a little bit higher. Now you're pretty close to what the true value is, right? And if you keep doing that, you'll just increase the precision. At this point in time, you will think that the teapot is better than the string light, even though it's the other way around, just because you don't really know much about the string light. So when you shift your gaze to the string lights, you can fix that. You also didn't really know what the value of the string lights was because highly uncertain, didn't know anything. But as you sample information now about the string lights, you can like move up. And ultimately, if you keep doing that, you will make the right choice and you will choose the string lights. The intuition that I want you to take away from this is that the longer the options are sampled, the better their values are known. And the ways in which they're not known have a pattern, right? Like the biases that you have when you don't know, that's systematic. So here I'm just plotting how the value changes over time, depending on what the true value is on the x-axis, and what you can see is the values initially with the very light blue lines, they're like biased towards the prior mean, right? So we're underestimating high value options and overestimating low value options, and that bias goes away over time as we learn about the options. Okay. What that means is that all else being equal, you will be more likely to choose options that are above the mean and less likely to choose options that are below the mean. That, however, is only true if we assume that people calibrate their priors to their environment, right? We can assume alternative priors, like a zero prior, for example, which is implicit in the attention diffusion model, which I told you about in the very beginning on the first slide. And here, sampling more information about an option will always make it look better, right? Because you start from zero, and as you gather information about the option, you're moving away from zero. We can also say, oh, people don't rely on prior information at all. This is basically what happens in the flat prior. And the prediction that makes is that attention shouldn't matter, right? We should not have a systematic attention effect because you take the first sample that you get, and then you basically run with that. The only thing that happens is that your precision increases. All right, so then sampling shouldn't affect value at all. Now we still need to test that. And the issue is that, I've told you, according to this model that's been established now, there's different ways in which attention and choice can be linked, right? So it's not just that attention tells you something about the options at hand. If I just see what you're attending to, that gaze is also biased by what you currently believe about the options that you have. Now, it turns out people look at the thing that they want to choose. And so just correlating choice and attention doesn't really tell me anything about the underlying mechanism, right? All right. So what we need to do is we need to kind of cut that feedback loop between the estimate of what the value is and the allocation of attention. And that's what I tried to do in this sequential presentation paradigm. So what I did here is instead of showing participants all the options at once, I presented them sequentially. I made them alternate on the screen. It's a bit perturbing, but people can do it. And I showed them in these colored frames that indicated which button to press to select either of the options, right? So like blue for teapot and red for string lights here. And I manipulated the order in which I showed the options, how long I showed the options for. So there was always one that was shown longer than the other one, and what response to give all independently. And I did that also independently, importantly, of what the values of those options were. And I knew what the values of those options were because, as we do in this field, I asked my participants before I made them make choices. So, and we did this actually in 2 experiments. In each experiment, I asked them, here's a teapot. Tell me how much you like the teapot on a scale from 0 to 10, right? And then I did that for the string lights, and then I did that for like 300 other objects. And then I took the values that participants gave me, and I combined them into choice sets that varied in the difference in the values that people had given these options, as well as how much they like the options overall. We independently manipulated these 2 dimensions. And in experiment 2, I was smart enough to also ask them, how confident are you that this is how much you like this thing? And they told me that too. Okay. I'm not going to talk about the confidence today because this is an attention talk, but if you're interested in that, please take a look at our paper. All right. So we can now take a look at the predictions that our model makes when we look at what behavior should look like in this task. So when we put together, based on these systematic deviations in value from options, all else being equal, we would expect that for high value options, we should see an increased likelihood of people choosing the thing that they've been shown more. But for low value options, because they know how bad the thing really is, the opposite should happen, right? And that's also what it looks like in our simulations. And now we have 2 studies where we can test that. And we see the qualitative pattern. The effects are much weaker than in our model simulations. And apparently there's also situations in which you don't actually find that, but we're gonna look a little bit deeper into that in some very new data that we have. But in principle, we get that. And now we can compare these findings to these alternative priors that we have, right? So we can test this, or we can compare this to the hypothesis that people actually have a 0 prior, right? So none of these are like things that can harm or hurt you. So why would you want to avoid them, right? So And also, people don't necessarily have to rely on prior expectations. So if we look at predictions from a zero prior model, we see that people should always just choose the thing that they saw more, particularly when the value of that thing is high, right? And when we look at the flat prior model, we shouldn't see a difference at all because attention doesn't matter. And we certainly don't really see the zero prior thing. We also don't really see the flat prior thing, right? Among the options that we considered, the one that we proposed is the most ideal. Okay, so this is a probably yes for the Bayesian value estimation part of that model. Now the question is, how does that compare to the typical kinds of choices that we ask people to make in the field, right? Which is when we just show them all the options at once and we let them do their thing. So in Ruby's study, which he's gonna talk to you more about at our poster, which is number 8 today, if you want. We basically compared the two conditions. So here we had the sequential presentation condition that I just told you about, randomly interspersed with free viewing trials. And we tried to keep as much constant as we can without changing the whole thing that we're trying to investigate. So we still had these like weird frames that told them which hand to respond with. We were always showing feedback afterwards. But in the sequential presentation, they always had like 5 seconds to respond, but in the sequential presentation, we were messing with their attention, whereas in the free viewing, we let them do their thing. Yeah? Okay. This is what we expected to find. So for the sequential presentation, we expected to find the thing that I just showed you. In free viewing, we thought, well, people look at the thing that they want to choose. So what we should see is like a very prominent gaze choice coupling, which has been like reported in previous work. This is what we find. Our sequential presentation findings are not quite as pretty as some of the earlier findings we've had, but this effect is kind of there. And in free viewing, we see this like very, very strong main effect of attention, right? So people really do seem to look at the thing that they want to choose. The question is, how do they prioritize that thing that they ultimately choose? And do we see specific patterns in there that we can try and understand? So what I'm going to show next, if the clicker works with me, is the proportion that the chosen option was viewed, conditional on value difference and conditional on overall value of the set, with the intuition being that we should look at it. We should look at a thing more or consider it more worthwhile choosing if it looks much better than the alternative, right? If it's easier to see which one the better thing is that I should be choosing, then it should also be easier to prioritize it. And people should also be doing this more when the thing itself is better. So when overall value is higher, they should also be looking more at the thing because it just looks like a better option and therefore more likely choosable. And we can use our sequential presentation condition basically as a reference, right? They also chose the thing. If there's really just a coupling between like seeing a thing and then choosing the thing, we should see the same pattern also in a sequential presentation, but not in free viewing, right? So that's just our baseline. Is there a passive mechanism that can generate the same pattern? Okay, so we do see the prioritization that we expected in previewing. As the value difference increases, it's easier to see which one the better option is, which one should pick. We see that people look more at the thing. We do not see this in sequential presentation. So an alternative model where people say, oh yeah, like people choose like the last thing that they look at just because, you know, you're more likely to hit the bound while you're looking at the thing and stuff like that. For the final thing, that could still be true, but that does not account for this coupling between gaze and choice. And we can also look at the effect of overall value. Here we also see a pretty strong effect of prioritization. So people look more at the thing they ultimately choose when that thing has a higher value, so is like a more attractive option. And we don't see that same pattern in sequential presentation. So that's probably not a bottom-up effect. All right. So People prioritize options that are likely to be chosen. Why, I can't really tell you. I don't think that mechanism is clear. In two option choice, people shouldn't actually be doing that. It's not optimal. They do it anyway. Makes any sense when you have more than two options. One thing we were looking at, and that was a bit of a post hoc thing, is that at least in the tasks that we have where we compare these trials, people were much better at the previewing things. So now you could say, well, the other thing is kind of a perturbing task. So here I'm showing just the probability that the left item will be chosen as a function of its relative value over the right item, and that's just response end. So they are more accurate in previewing when they can get the information that they want at the pace that they want it. Intriguingly, we also see that they're faster in previewing, particularly in the case when they can prioritize, right? So I showed you that they prioritize more when value difference is high. They also show a greater advantage in previewing when value difference is high. I showed you that they prioritize more when overall value is high. They also show a greater advantage in response times when overall value is high. So that's why our current hypothesis is that, or our current conclusion is that attention prioritization affords more efficient choice. So that's the point. It just gets you there faster, more efficiently. Okay, so now we figured that out. Now the question is that something that is inherent to value per se? Is that a general thing? Or does it depend kind of a little bit on what you want to do? And so we have some previous work here where we thought, well, when you're faced with a set of options, you don't always choose the best thing. You can do a bunch of different things with the options that you choose. Aside from the fact that you don't always have to choose based on value, even if you do choose based on value, you can choose the best thing, but you can also choose the worst thing. And we have some work where we show that you can basically just flip the value scale in the choose worst case, feed that into an accumulator model, and you get the types of choices and the choice dynamics that people exhibit. So that's nice. And our model predicts the very pattern that we've seen across many, many studies now, that this overall value effect of people being faster when choosing among higher value options is replicated in choose best, but it actually flips in choose worst. And the model explains that, and people do that. So here, though, the point is to best separate the values of these options, right? You want to really understand which one is the best one, and separate that from the other ones in order to be able to pick it, or the worst one. In either case, you need to separate them out. But there's other kinds of decisions that you can make about options. For example, how much you like them as a set, right? Think about you have those in a gift basket, and you need to think about how much you're willing to pay for them in total. What you have to do is you have to integrate the values of those options in order to make a choice about them as a set. And we've modified our model, and I'm not going to talk about the details of that, but you can come find me and chat with me about it if you're interested. And we've modified our model, and the model can also, with some switches, basically generate appraisal choices where how much they like or dislike the options varies with overall value in a sensible way. And then the model predicts that the response time should always be an inverse U-shape, and that shape shouldn't be sensitive to whether you're saying how much you like or dislike them. And we have tested those predictions of the model in a study in collaboration with Sebastian Glu's lab, and we basically confirm the prediction. So what we find looks like what we expected to find, which is nice. But today, I want to focus on the eye tracking data that we collected in this study, where the question is now, do we still see a relationship between attention and value, or do we actually see a relationship between attention and what we're trying to do with that value? So the first thing we did is we looked at choice, and we checked whether we can replicate a previous finding, which is that people will attend more to options that are congruent with the current choice pool. And indeed, when choosing the best option, people will look more at higher value options, like we've seen in Ruby's paper too. But when people want to choose the worst option, they will actually look at lower value options more. Yeah. But now what happens in appraisal? We have no idea. We talked to Fred about it, and Fred said, I hereby pre-register that people should allocate their gaze evenly because that's how you get the most useful information for the type of choice that you want to make. And Fred is always right. So what we found is that there is no effect of value on gaze allocation if you look at it just over the entire course of the trial, right? So no value or goal specific prioritization in that. Okay, but we can also look at this a little bit more over time, right? So that's an aggregate over the whole time course. And if we zoom in, what we see is, so on the left, I'm showing you I'm overall showing you the probability that people will look at the highest rated item over the lowest rated item. On the left, I'm showing you that for choice. On the right, I'm showing you that for appraisal. Black is always the positive frame, right? Choose best or about like appraise liking. And red is always the negative frame. So choose worst or appraise disliking. What you can see is like already just the pattern on the left and the pattern on the right are very different, right? So on the left, we see that there's a goal congruency effect where people will look more at the goal congruent thing than the goal incongruent thing. And that happens both early on as well as later on towards the choice. Whereas in appraisal, they really go back and forth. So for every positive effect, we have like a subsequent negative effect, right? And that keeps happening over time. That's why we don't see anything on average, but there's still a pattern there that we can detect statistically, which is cool. People allocate their attention differently depending on what they want to do. For people who study attention, that's totally trivial. But for people who study value-based decision making, we haven't thought about that. All right, so we have like early and late goal-dependent attention prioritization in choice, whereas we have this oscillating search across all options, right? That is important if you want to integrate those values. So now I'm also going to flash at you what that looks like response log, just so that I can show you that this rank effect really emerges over time in choice. So now like on the, it's all time locked to the response, like on the very right of each panel, there's the response. And you see that these effects basically emerge as people figure out like what the goal congruent option is, right? And then we have this like back and forth still in appraisal. Okay, that's basically what I wanted to tell you. I'm going to show you the pretty figure again. Take home is there's basically two distinct effects in which attention shapes choice, right? On one hand, it gives you information as you are faced with an option. You have an opportunity to sample it, to learn about it. Like in this case, from memory with cognitive actions, not with actual hand actions or eye actions, or however people gather information. But you also can change what you're able to sample from, right? And people do that in a very systematic and meaningful way. So you have this like goal-dependent attention prioritization. And what we're thinking is that this attention prioritization, to the very least, just makes you more efficient. Okay. With that, I would like to thank all of my collaborators that have contributed to the projects I told you about, and the people in my lab. And remember, Ruby has post-rate in today's session, and go and have a chat with her. And if there's anything that I didn't tell you about, but that you're interested in, come check me out.